For a data set that's already organized into a grouped frequency table, we're not really able to calculate the precise mean of the data set because we can't see the individual data values. However, we can calculate an estimate for the mean. To do that, we're first going to look at the midpoint for each interval. Looking at the first group that goes from 50 to 56.5, we can find the midpoint by adding the left and right boundaries, then cutting them in half. That'll show us the point that's halfway between the lower and upper boundary of our class. So for that first interval, our midpoint is at 53 1/4. We'll repeat that process for all of the intervals in the table. We'll keep track of each of the midpoints because we're going to need to multiply each midpoint to the corresponding frequency. We're going to add all of these products, the frequency times the midpoint. This sum will serve as the approximation for the total sum of all the data values. Now the last step is to divide by the total number of data values, just like we do in the calculation for the mean. So our estimated mean is the sum of all the frequencies times the midpoint for each of the class intervals, then divide by the sum of all the frequencies. So I'll copy our frequencies over as multipliers to our midpoint. So we have 1 times that first midpoint, 0 times the second one, which is going to knock that out completely. 0 times anything is 0. 4 for the frequency here, another 4, 2, 3, 4, and 1. We'll find each of these products and then we'll add them all together, and that result will give us the sum of the frequencies times the midpoint. Next, we'll need to add up all of our frequencies to figure out what the sum of the frequency is. We can just add down our frequency column here to find the sum of all of our frequencies. For this example, the sum of the frequencies times the midpoint comes out to 1,460.25, and the sum of all the frequencies comes out to 19. So our estimated mean would be 1,460.25 divided by 19. And that comes out to be 76.855. So we're going to approximate here. Let's just round to the nearest tenth. We'll call it 76.9. So the average, or the best estimate for the average for this statistics test, is 76.9.